Hello everyone, welcome to session 68 of Selenium training. In this session, I am going to explain about Jenkins, Git and GitHub guys. Okay, we are going to start Jenkins, Git and GitHub concepts. Fine. Before you understand why we use Jenkins, Git and GitHub, okay, we have to understand like how to configure them first. Okay, let's first configure them and later point of time when the time is I will explain where exactly we'll be using Jenkins, Git, and GitHub. Anyhow, I will be explaining the process of working in a group and what's the requirement for this Jenkins, Git, and GitHub. Okay, fine. Now let's get started with today's session, which is on Jenkins, Git, and GitHub. Fine. Let me explain the process of working on a project in a group, guys. For example, don't worry about this. This is just for my reference, guys. Don't bother about that. Okay. Let me draw something. Let's say, guys, there are 4 people in the project. Let's say there are 4 people on the project. And the first guy's name is like Mr. A, Mr. B, Mr. C, and Mr. D. Like this, there are 4 people on the project. So guys, tell me, in general in a project, will there be a single person or more than one people working together?
Multiple person.
Yeah, multiple person will be there on the project. But how can a multiple person work on a single project where everyone is writing their own automation scripts? How can they be on sync, right? There will be some conflicts or not? Mr. A will be working on something, Mr. B will be working on something, Mr. C, Mr. D, okay, and but they are on the same project. Will there is a possibility of conflict or not?
Yes.
There's a possibility of conflict, right? So if they don't plan properly, there is a problem of conflict, okay? So redundancy of work may be there, or Mr. A will be writing some automation script for the same functionality for which the Mr. B is writing the code, okay? And when they merge, nothing will happen, right? The problem is like whether to go with Mr. A's code or Mr. B's code, and why first in place Mr. A and Mr. B are working on the same module, okay? So some planning is required and everyone has to work together. But okay, why we require more people? Because our project automation, if everyone works together, then we can soonly finish the automation code, right? Soonly complete writing the automation code or something. But here, even though we have multiple people, the problem arises where Mr. A, Mr. B, Mr. C, and Mr. D should understand each other and work together. Okay, Mr. A should know where he is working, and Mr. B should exactly know where he should work. Mr. C where he should work, and Mr. D. And at the end, all their works should be combined, guys. Okay, they should work in a collaborative environment rather than working independently and doing their own stuff without any planning. They have to do work in a kind of understanding environment where they collaborate with each other and contribute to the progress of the project rather than disturbing the progress. Fine. So in this session, I am going to explain with this, in this concept, I am going to explain how these people are going to work together in a proper manner. Okay. Let's assume that there is an application. Let's assume that there is an application having this functionalities, guys. One is, let's say I'm just taking a small application, say it has login. Registration functionality is there, then login functionality is there, home page functionality. I'm just taking a small example, guys. This may not be the real-time case, but assume that particular application is having only these 4 modules. Okay, registration, login, home page, and logout. This is the application. Let's say that this is the application having these 4 modules, and this particular application having these 4 modules need to be automated. For that, 4 people got assigned to the project to automate this particular code for these 4 modules. these 4 people were assigned to this project. So guys, so Mr. A can work on one of the module, Mr. B can, I will explain what is going to happen. For example, Mr. A has been assigned to work on registration module. Okay, let's say Mr. A is working on which module? Registration module. And Mr. B got assigned with to automate login module. And Mr. C was asked to automate homepage module. And finally, Mr. D was asked to automate the logout functionality of the application. Like this, 4 people are in the initial phase. 4 people got started working on different modules of the application. They divided it properly and they started working together. Okay. So let's assume that Mr. A completed this automation first. Okay. Out of all these people, Mr. A, Mr. B, Mr. C, Mr. D, Mr. A completed the automation of this registration functionality in the first go. Okay. So he completed it, automating this particular functionality fast, and he's ready to update into the project. So guys, how can Mr. A share this completion of this registration automation code to Mr. B, Mr. C, Mr. D? How can he do that? How can Mr. B, Mr. C, Mr. D get this automation code? Everyone has to collaboratively work, right? What's the possibility, guys? Can anyone?
Central repository.
Yes. We have to, they will at a project level, they will maintain something known as centralized repository. Okay, this is a centralized repository. A central location at a high level. Okay, the central repository will be maintained where everyone will be collaborating together. Okay, this particular thing will be accessible for Mr. A, Mr. B, Mr. C, and Mr. D. Okay, everyone can access this as a central point. Since first of all, Mr. A has completed the automating of this registration functionality, let's say 1.0. Okay, registration 1.0. So what he has to do? He has to save this code. He has to push this particular code into the centralized repository. Okay, let's say this process we can call it as something known as you will check in. Okay, you will check in the code. You can see here, check in. Mr. A has completed this registration automation of this registration functionality, has checked in the code into the centralized repository. So once he check-ins, what will happen? Here, registration 1.0 will be available. Whatever the code, this part is nothing but the local machine of Mr. A, guys. This is nothing but the local machine of Mr. A. This is a local machine of Mr. B. This is a local machine of their own personal computers, you can say. Okay, everyone has their own computer, right? So Mr. A has started developing the automation code for the registration functionality and he has completed it. And he named that particular initial version of the completion as 1.0. Let's assume that. So in the local machine, this registration automation code is there, which is not accessible by Mr. B, Mr. C, Mr. D. To make this local code available to everyone, he checks in the code into the central repository, and this is nothing but registration 1.0 code has been checked in into the centralized repository. Fine. Tomorrow, at this point, guys, registration 1.0 went here. Okay. Now Mr. B has completed this login. Mr. B has completed this login, and also similar to Mr. A, Mr. B also want to make his login code available for everyone here. He wants his automation code to available for everyone in the team. What should he do, guys? What should he do? Tell me, guys, anyone?
Check in.
Can he directly check in?
No.
Why? What will happen if he directly check-ins?
Maybe Mr. A code will be get removed.
Yes. So Mr. A has checked in the code of registration 1.0 into central repository. Now when Mr. B tries to check in the login functionality, does he has any registration code? No, right? So when he checks in, automatically this code will be removed. This registration code will be replaced with this login. Then what is the purpose, guys? Is any collaboration happening or not? If he also check-ins, the collaboration will happen or not?
No.
No. The problem here is login code will replace the registration code. Any solution?
So before he check in, he
Check
can
out.
check out.
Yes. Yes. So yes, he has to 1 minute. So he has to, before check-in, he need to check out this code, or we don't say it as checkout. He need to like 1 minute.
Which
Update or checkout. So got confused. He will check in the code, and in order to get here, we need to get the existing code. So for that, we need to either check out the code. He need to retrieve this code into his machine first of all. Okay. Once he will retrieve this code, this process is known as checkout. Mr. B checks out the code. What will happen when he checkouts?
Mr. A registration code also with Mr. B.
Yes, Mr. S. Okay, Mr. S code will come here. Okay, registration. It will come to which location? Into his. It will
Local
come to
machine.
local machine of Mr. B. Okay. Now, Mr. B, what he has to do? Mr. B has to
Check in.
now he has registration 1.0 and login 1.0. Both of the things are there. He need to now push the complete code. Okay, the one that is there in this local machine along with the registration 1.0 which has been checked out into his machine. Okay, he will do one thing, guys, like he will now check in the code. What will happen in this case? Now in the central repository we'll be having both. What are they? Registration 1.0 and another one is
Login
1.0 will be there. Okay, so now this is what we have to do, guys. This is what we have to do. Okay, now so we simply said checkout, that's fine. One more thing here is, when do we have to update? When we have to check out and when we have to update? Can anyone say the difference?
Update means suppose if you are doing any check-in, before check-in we can update the repository.
Yes. Okay.
And once we are done with our functionality, then we can do check-in.
Fine, understood. So the thing is that the thing here is that there is small difference, guys. Checkout and update. Okay, when we have to update and when we have to check out. Checkout is something when you don't have anything, guys. Okay, initial checkout. Checkout will be done when there is nothing in your machine. Okay, for the first time you are doing. So let me go back. I will explain it a proper way. Some small disturbance is there here. So let's assume that Mr. has checked in. Registration 1.0 is there here, and Mr. B has not started working it. Okay. Let's assume that Mr. B has not started working on this login 1.0. For now, he is a new member to the project. He is a first member and he has checked in some automation code. Registration 1.0 is there here, okay, in the central repository. And Mr. B has recently joined after Mr. B, or he has been assigned recently to the project. Let's assume that. Now he don't have any code in his machine. What he has to do first? He don't have any code.
Check out.
First thing he has to do is he has to check out. Okay. Freshly he has been assigned to the project and he has not has any code, so he has to check out. Once he check out, the complete automation code that is currently there in the centralized repository will come into the local machine of the Mr. B. This is what will happen, guys. So here also registration 1.0 will come into this local machine. Now we'll start working. Now Mr. B has started working on login functionality. Let's assume that login 1.0 he completed it. He completed it. Immediately after completing it, there is a possibility that some other person has also contributed to this code. Okay. Before checking, he checked out, guys. He checked out and started working on login 1.0. But before checking in this login 1.0 along with this registration 1.0, some other person may have. There is a possibility that some other person may have updated this code or not.
Yes.
There's a possibility, right? So you cannot blindly, because for developing the login functionality, there is some time frame needed. In between that, many people are in the project and some people may have updated the code. We don't know. When he has checked out the code and in between check out the code and trying to check in, right, there's a possibility of other people updating this code in the centralized repository. We don't know. So make sure that whatever the code is trying to check in is updated or not. Okay. Whatever the code he is trying to check in along, this is the latest code. Whatever is trying to code addition thing is login 1.0 is additional thing. Registration 1.0 is already there. There may be possibility that Mr. A itself has updated the registration code. We don't know. But initial checkout is happened to get the code. But at later point of time when trying to check in, by the time the login functionality is login up, automation code is ready, some other people may have updated this code. That's the problem. To check whether we are checking in the latest code or not, what Mr. B will do is he will, before checking in, as a second phase, he will try to update the code. Okay. He will try to update the code. If we don't update, what will happen, guys? If we don't update, what will happen?
Conflict.
Yeah, conflicts may come because whatever the code that is there in Mr. B is older code, and whatever that is there in the centralized bus is the latest code, and you are trying to replace the latest code with the older code, right? Updated code may not be there here. Like you are not pushing the latest code, rather you are trying to push the older code. By the time other people have already updated, this is a problem, guys. If everyone is working together, this is a general problem. So before checking in, everyone responsibility is to update the code with the latest. Okay, don't worry if whether that is updated or not, you have to update it. So what will happen when it gets updated? If any updated code is there here, that will come into the local machine, and then in addition to that updated code, login functionality will be pushed here. So for that, we have to, Mr. B will check it. 3-step process, guys. Okay, 3-step process. This is 3-step process. First thing is that brand new user has to check out the code into his local machine, and he has to work on something. By the time he works on something, some other people in that same team may update this centralized repository. To make sure that you are pushing the latest code or not, you need to first update the code. Whatever the code that he has checked out may be older code. So you don't have to check out again and again. Instead, if some code gets updated in the centralized repository, you need to update into your local machine. Then you have to check. Okay, before checking in, you need to update. Okay, before working on this, you have to check out, and before checking in, you need to update. Clear, guys? Any confusion here? Any confusions?
No.
Clear for everyone? Others, guys? Any confusion here? Let me know if
No.
So fine. Just imagine that you have 4 people in the project and just assume like that. Okay. So everyone will be facing the same problems. Fine. Now tomorrow I will explain. It will be more clear going forward. Just wait for some time. So now let's take the turn of Mr. C. After Mr. A and Mr. B, let's say Mr. C also got added to the project, and he don't have any code in his local machine. What he has to do, guys, to get the local machine? What he has to do?
Check out.
Yeah. Others, please respond. Only one guy is responding. So he has to check out. Okay. The code has to check out. Initial phase. When he don't have any code in his local machine, first step is checkout. What happens when something checkout? What happens when you check out? When Mr. C checkouts, what will come here?
The latest version which is stored in the repository.
Okay, whatever that is there in the centralized repository will come into his local machine. So what is there in his local centralized repository? Registration 1.0. Other one is
Login.
login 1.0, right? These two things will come into the local machine. That's fine. Now, Mr. C started working on homepage. He's in process, guys. Okay, assume that in real time. So you are that person. Assume that you are that person. You are Mr. C, and you have as you are new to the project, to get whatever that is updated so far in the central repository, you have checked out the complete code into your local machine, and complete code that is there currently in the central repository has come into your local machine. That is registration 1.0 and login 1.0 came to your local machine. Assume that you are the Mr. C. Now your project manager or project lead has asked you to work on the homepage functionality. Okay, homepage functionality, and to his instructions. So you already have this code. So you started automating this homepage functionality in your local machine. Okay, while you are working, and assume that another person also joined into the project. Let's say let's forget about Mr. D for now. So while you are working on the homepage, Mr. A has updated this registration 1.0 with something, let's say 2.0. Okay, he modified some registration code. Okay, while you are working on home page, before you check in, Mr. A has been asked by the manager or project lead to update this registration 1.0. He identified some mistakes in registration automation code and he asked to update, and Mr. A has done that. And before you check in this home page, what Mr. A did is like, what is the second step he has to do, guys? He modified registration functionality. Okay, so what he has to do here?
You need to check in.
He need to
First, he need to check out. Then he need to check in.
Yes, first thing is that before he updates the code, he has to check out, right? Do he need to check out? Is it required to check out?
No.
No. What should be done?
Check in.
No.
Update.
Yeah, you need to update the code, right? If he updates the code only, when he updates, what will happen? He already has registration 1.0. When he updates, what will happen?
Updated code will be in central repository.
Yes, yes.
The
Whatever the updated code
registration 2.0 will be stored in the centralized repository.
before working on this registration 1.0, what he does is he will modify this, no problem. He will modify this 2.0, that's fine. But before checking in this registration 2.0, he will update it. Once he updates it, what will happen? This login 1.0 will come and fall here. Okay, login 1.0 will come and fall here. There are two ways, guys. You can, if you see that lot of code has been done, lot of code has been modified in the central repository, as a fresh instance, you can completely check out, not a problem. Okay, you don't have to update every time. There are two possibilities here. Either you can check out the complete code or you can update. Both are right. Both are right based on the situation. So tell me now, when you will update, let's assume you are Mr. A, when you will update, when you will check out in this situation. At what point you will update and what point you will check out.
Any modification or any changes in the existing?
If you think that, for example, by the time you thought of changing the registration 2.0, it's been a 1 month gap, let's say. What you will do? You will update or check out?
Check out.
Yeah, check out. Check out is the correct one, because by the time 1 month, right, lot of modifications have been made in the project, and it's like lot of, let's assume that not these 4 people are there. Many people are in the project. Let's say 10, 20, 25, 30 people are there in the project. Okay. So lot of people will keep on doing all the stuff, and its updation is not the correct solution. Okay. You have to get a fresh instance of the current instance. At that time, you have to freshly take a new code thing. You will fresh in your local machine, you will completely check out the complete automation code which has been done, over a period of 1 month or something like that. Okay. If the duration is long, you have to check out. If the duration is very less, every day you are continuously working, in that case, update is fine. Okay. So it's up to you, like how you feel comfortable. If you feel that, okay, let me get a fresh instance without any problem, you can simply check out and work. If you think that just now I just did that, just let me update the code and do it, that's fine. Update, you can update. Okay. For small things, you can update. For major things, you have to check out. Okay. You have to keep that in point. Now, since the changes are very less, let's update. Okay. Let's update. So I updated it. When I updated it, in my machine already registration 2.0 is there, and along with that login 1.0 and came into picture. Okay, login 1.0 came into picture. So here guys, these two things are there. Now you will, what you will do here, you will check in the code. Finally you will check in the code. Again you will check in the code with the latest versions. Before checking in, you have to update it. Even though you check out, you have to update and check in, guys. Remember, before check-in, update is mandatory. Okay, don't blindly check in. You don't have to check out and work on that and then check in. Okay, before check-in, you need to update and check in, because by the short span of time, some people may have updated the code in the centralized repository. This is the problem. Okay, this is the problem. If you have to work together, you have to follow these rules. Otherwise, things will go wrong. You will face a lot of problems. You will try to push the older code with the latest code. Okay, this is the problem. Okay, I will explain how the things will go in more in real time. For now, let's understand these concepts of check-in, check-out, update. Okay, so initially you have to check out. That's compulsory. In the first go, when you are new to the project, you have to first check out. There's no other way. You cannot update directly. Later point of time, based on the time gap, you can decide whether to check out or update. Okay, check out or update. Checkout means complete new code will come. Update means existing code will be updated. Anything you can decide. Okay, anything you can decide. So here Mr. C. So now Mr. C has completed home page. Okay, home page 1.0. Tell me guys what he has to do now. He want to check in this this latest code. Okay, of home page 1.0. What he has to do now? Anyone?
Check out.
Checkout is already there, right? Okay, you are saying checkout. Checkout means fresh instance will come, right? Yeah,
Yes.
registration 2.0 happened. Okay, only thing that got different is 2.0. 1 minute. It's not okay. Yeah, here 2.0 came into picture. Registration 2.0 already there. This has been done by Mr. A. Now Mr. C is done where he has worked on home page. So there are two possibilities. One thing is that we'll keep this repository like this only. This code will be there like this in your machine. Along with that, what you will do is, while keeping this aside, as one said, you can even check out also, not a problem. Okay, you can check out also as a fresh instance. You can check out as a very fresh instance. So in your local machine now, two codes will come. When you check out like this, in this case, two codes will come. One is this particular code, older code. Another one is the latest code like this. Okay, here what will be there? Registration
2.0.
2.0 will be there. Here login 1.0 will be there. Will home page will be there or not here? Will there be any home page here?
No.
No. What do you have to do?
Check in.
Lockout.
Simple thing here is you have to copy your this particular code into this code. Okay. Two repositories are there in your local machine now. Okay. In your local machine now, when you check out twice, what will happen? First checkout is this one. Second checkout is this one. Okay. Two copies are there. Now, when you check out for the second time, latest code came here, but home page will not be there in that. So what you will do in that case, you have to copy this home page into this second, and then you will ignore this one. At later point of time, you will ignore this one. And finally, now you need to check in. So can you directly check in here in this case? Yes or no? Can I directly check in this code into the central repository?
No.
No, you should not do that. Instead, you need to update the code. Just before checking, there's a kind of prerequisite, guys. Okay, you have to update and check in. Nothing will happen. Nothing will happen. Just update and check in. Okay, so update. So there is one more problem here, guys. When you update, what will happen? When you update this code, what will happen? Any problems will happen in this when you update? Anyone? This code will update this code. So if I update this particular code with this particular code, what will happen?
Conflicts will come.
No, homepage will go away.
Okay.
Right or wrong?
Yes.
Yes, right. When you update the code, this is the latest code you are updating here, and homepage may go away. Okay. This you are updating this code with this code, and this homepage may go away. In that case, what you will do here is whatever the repository there is here, right? Once updated, again you need to copy this homepage 1.0 to here and immediately check in without any. You should not waste any time. Okay. Once you update, directly check in. Try to check in as soon as possible. You have to check in. You should not give 10 minutes, 20 minutes, 30 minutes of time. Okay. If you again take 20 minutes, 30 minutes step, again you need to update this. Okay. If you are taking more time, maybe 5 minutes, 10 minutes also, multiple people will be working on the project. You don't know at what point of time who will be checking in, right? Who will be checking into the centralized repository. So better before checking, immediately before checking, you have to update and copy paste this code into the latest code that you have worked into the updated repository and then push checking like this. Check in like this. Now here, what will happen here? Homepage 1.0 will come. This diagram may look kind of bit complex, guys. There's no other way. Okay. So you have to understand the real-time perspective. What will happen when you update? What will happen when you check out? What will happen when you check out for the second time? Okay. And before checking, you have to update every time. What will happen if you update? This will get replaced with this code. So you better keep a copy of this and then paste here and then push it. Update, copy paste and check in. Update, copy paste and check in. This is the process. This is the process. Fine. Similarly, Mr. D also same thing, guys. He is also new to the project. First, what he will do? What he will do?
Check in.
First, what he will do to get the code into his local machine?
Check out.
Check out.
He has to check out the code. Okay. Once he check out the code, what will come here?
The latest version which is
Latest
stored
code.
in the repository.
Yes. Login
And home.
1.0, then home 1.0. All these things will come into picture. Okay, that's fine. And he has been assigned to work on logout project. Okay, logout functionality. So he started working on. By the time he started working on, let's say the centralized repository got updated with some other code. That is, let's say this guy somehow push login 2.0. Okay, here 2.0 got pushed. Assume that your login 1.0 got updated with 2.0 somehow. Okay, don't worry about how he updated. Now he is ready with logout. By the time he pushes this logout into the centralized repository, the centralized repository got updated. What he can do? What are the two possibilities here?
Again check out.
Yeah, he can either check out, or if the time is very less, okay. Once the checkout time is, let's say he checked out, initial checkout he made it 10 a.m. today. Let's say the initial checkout he made it 10 a.m. today. Now the time is 11 a.m. Now the time is 11 a.m. Only 1 hour happened. In 1 hour, he completed this logout. Will he check out or update? It's better to, even though the time is very less, it's better to check out, guys. Okay. Why we have to check out? Why we have to check out here? Generally, I prefer to check out, guys. I don't know about others, but I prefer to check out because even though it's 11 a.m., very time span is very 1 hour only is the difference. But still, I will plan to check out because when I check out, I will get another repository in my local machine. This I will consider as old. Oh, sorry, where did it go? Sorry, here it is. 1 minute. So this is the old one. This is the latest one. Okay, this is the latest code. In the latest code, this logout will not be there. Okay, this instead of directly updating, what I will do is I will again check out the code so that I will get another repository of the code in my local machine, and with the latest code, it will be there. Minus latest code minus logout will be there. Okay, only logout will not be there. Simply what I will do, I I will now, if time lag is more, I will again update the code, and after updating the code, I will simply copy this logout into the latest checkout code, which has the latest checkout code. Okay, latest and updated checkout code will be there, right? That into that logout will be pushed, copied. The code I will manually copy paste the code, guys. Okay, I will go to the framework and all the respective files wherever I have modified the code, right? That particular code I will copy into this latest code. And once things are good, without wasting any time after update, I will directly check it. Okay, I will directly check in the code. This is checking. I will check in the code. You have to understand this process, guys. There is no other way. Okay. So here, what will happen? Logout 1.0 will come into picture. Guys, any questions from this? This diagram looks odd, but there's no other way to explain. So, any doubts here? In the above process, any doubts here? Getting any clarity, any confusions between checkout and update?
It's clear, Arun.
Okay. Fine. So that's the basic thing you have to understand, guys. Without understanding this thing, why we are doing this, even though you understand Git, GitHub, and Jenkins, it's no use. Okay. So you have to better understand this part, why we are working together, how we are working together, how we are checking in the code, how we are check out the code, how we are updating the code. Okay. There are several commands for that. I will explain later point of time. Okay. But at a high level, if I have to summarize everything, if I am a person in the project, what I will do here is, whatever the case is, there will definitely, when I am got assigned to the project, there will be some centralized repository, right? Centralized repository where everyone will be updating the code will be there. Okay, checking in the code will be there. That's fine. So if I'm this person, if I got assigned to this project, so initially I need to check out the code. That's the first thing you have to understand. Okay, initially you need to check out the code. Once you check out the code, the complete latest CR code will come and place here. Okay, CR code will come here into my local machine. This is my local machine. Into my local machine, the centralized repository code will come and will get copied. You just simply copying this code from the centralized repository to your local machine. That's it. Okay, this is the code of the centralized repository. It got copied into your local machine. This is the first thing you have to do in any project. Once you do that, okay, you need to work on something. You will update something, whatever the task that is assigned, right? You will work on that problem, work on that automation code, In general, I will do like this. Okay, so I will work on the task that got automation task that got assigned in this particular code. Okay, so it may be updating of the later whatever the code that is there, right? You may be asked to update the existing code, or you may have to write the new code, whatever that is. You do some changes. It may be new addition, it may be updation of the existing code, whatever that is. Okay, somehow you will work on this code. So before I check in this code, okay, before I check in my automation code along with this CR code, what I will do is, it's better that I will check out the code again to my local machine. Okay, I will check out the code again to my local machine at a different location. Let's say this particular code, initial code, is at location A in my machine. Let's assume that. And again, when I check out the code and at a different location in my, like it may be C for any drive or any folder drive or something. Okay, different place in my local machine. Let's say I'm just naming it as B for now, just for explanation purpose. So again, I will get the CR code, which is kind of latest when compared to this old. This CR is old. The CR may be new. Okay, this CR along with this, what I will do, I need to, before updating, if I get any delay here before checking in this CR code along with this work copied, okay, what I will do is I will first update the code. Okay, while checking in, I will update the code. This same CR code I will update. Second point is I will update. After update, after updating, I will copy this. I will copy this. Whatever the work I did, right? I will copy this work into this updated code immediately without wasting any time. I will check in this code into the centralized repository. Okay, this is check-in. This is what will happen, guys. Individual perspective. I'm not talking about when you have a large team, right? I have explained like this, right? Even you have a large team here. When you are individual person in the particular team, having many people who are working on the same automation project, you will be doing like this. Okay, initial checkout will happen after you work. Okay, we will take another checkout which will be stored in a different place in your local machine, and that particular code, if some time has happened, time lapse happened, you will update the code immediately. You will copy the whatever the work you did, right? That places of code you will modify that in the modifier or copy paste that kind of work into your second repository, which is the latest and updated one, and immediately check in without wasting any time. There should be very less time between the updation and check-in, guys. Okay, this rule here is before checking in, the updation should happen. That the time gap between the check-in and updation should be very less. If the time gap increases between the update and check-in, what do you have to do, guys? Tell me what. For example, you updated the code and there was like some 10 minutes of gap. Okay, and now you are trying to check in. What you will do in this situation? Anyone? I updated the code, but I wasted 10 minutes of time. I didn't check in till 10 minutes. Okay. Now I'm planning to check in after 10 minutes of updation. What I will do? What I have to do?
Check out again.
Only 10 minutes, right? You already checked out in a separate place. Here I already checked out. This is a A location. This is a B location in my machine. In A location, my work is already saved mode. Okay. In B location, I checked out. Only 10 minutes gap. 10 minutes is more high. You have to again update this. Okay. You need to again update the code. In this case, you have to update the code and again copy paste the work into this location and check in. There should be very less time gap. Okay. You will not do checkout every time, guys. Okay. Why I'm doing checkout here? To have it, I can copy this work into this. If I wrongly update this one with the work, what will if I don't check out again and if I update here directly, what will happen? Tell me. So if I assume that I didn't do checkout for second time, okay, but first time only I did, and the work has been updated, work has been written here. I did some work. Now if I update, what will happen? What will happen, guys, if I work on this? If I update this same repository, what will happen?
The work that I made, that will not be reflected in the repository.
Yes, it will be replaced, right? This whatever the central repository don't have any work, right? So whatever the work I did will not be there in the central repository because I didn't check in. But if I try to update the checkout repository which has some modifications, simply without your notice, this will get replaced by this CR code. So work will be lost. Your work will be lost. That's the reason I check out for the second time. Okay, I check out for second time because this checkout will place in the latest code will come into the different repository. Now I can simply copy paste my work from the repository 1 to the repository 2 in my local machine. That's the reason only I just check out. Okay, check out for second time. But before I check in, there may be some possibility that okay, after checkout for second time, I just wasted 10 minutes of time or something like that. Okay, and when I try to check in, some conflicts may come because when why the conflicts may come when I try to update, when I try to check in.
The 10-minute gap.
The 10-minute gap, some other person may have updated this code, right? Some other person may have changed the centralized repository code. So your code may not match this version and then some conflicts may come. That's the problem. So what you have to do in that case? You have to update the code. You have to update the code. Update the code, again copy this work into this second repository and then try to check in immediately. If you don't check in immediately, what do you have to do? Again 10 minutes gap came, let's say. After updating also some 10 minutes gap came. What you will do?
Update.
Again you have to update. Second time you have to update and check in. Okay. But when you update again, this work will be lost. What you will do if the work is lost? For second time when you update, this work already copied work will be lost. What you will do? Again you need to copy this work from the repository A to the repository B and then check it. Okay. Clear, guys? Clear? How you are going to work in real time? Is it clear? This is the actual flow, guys. Okay. You have to focus on this part. This is how I work. Okay. This is the best thing I feel. Easier way I feel. Whenever I work on my projects in real time, right? I generally work like this. I check out the code. I do some modifications. I add new code or whatever that is. And instead of updating the same code, I will again check out so that another repository will be created in my local machine. After a new repository got created in my local machine, I will simply copy paste, okay, this work here. If I feel that after I check out before copying this, if there is more time happened, I will again update the code with the latest code. Okay, update. Simply instead of checkout, I will update and simply copy paste this work and check in. That's how I do. That's how I do. If I feel between updation and checkout, check-in, updation and check-in, some gap has happened, again I will update the code. Okay, again I will update the code from the central repository and I copy my work immediately and I will immediately check in without wasting any time, because within a span of time, even in minutes, guys, in minutes, other people may update this code. Okay, other people may change this CR code, central repository code. So that's the reason we have to be very fast while checking in. Okay, if you are not able to check in, simple as that, update, copy your work again and check in. That is a repetitive process for you. Until you check in the code, you have to keep on doing this stuff, guys. Otherwise you cannot move forward. Okay, so like this, guys, people has to work together to work collaboratively. There is no other way. Okay, people has to collaboratively work in this process. Everyone has to follow the same process in the team. Okay, they have to check out, update, check in, all those stuff they have to do. Okay, there is no other way. Fine, that's a theoretical concept, I understand, but there is no other way. This is a very important thing to understand. If you understand this part, then this installation configurations are very simple things to understand. Fine, a lot of settings you need to do. Fine. Fine, this part I explained. Okay. Now, so this thing, how to make this thing possible in real environments? In real environments, how to make these things, this versioning, this checkout things, check-in things, how to make these things possible? So we make this approach possible. We make this kind of approach where everyone can be checking in, checking out. If you improperly check in, what is happening, guys? If you try to improperly check in, what is happening? You may get some errors. You may get conflicts. You may not be allowed to check in. Okay, some errors you may get. You will not be able to check in if you don't follow the process. So such kind of things can be implemented with the help of these tools, guys. Okay. Mostly these things, Git and GitHub. Jenkins is a different thing. Jenkins is something like about continuous integration, whereas Git and GitHub is a version controlling and collaboration tool. Okay, collaboration and version controlling purpose, we use Git and GitHub. For central repository, we'll use GitHub. For checking, checkout, update, we have some Git commands. Okay, we'll have some Git commands. Jenkins is for continuous integration. I'll explain later point of time. Okay, what is continuous integration, all those stuff I'll explain at later point of time. Fine. So here one more thing to understand about Jenkins. Suppose, guys, there is another problem. This things you are following fine. That's fine. Okay, you are following this process. You are able to update the code. You are able to make changes to the central repository from your machine by following this approach. Okay, this approach. When you are working as a team, let's say you are Mr. B, and before you check in, Mr. A has updated this centralized repository. You have taken that updated code and then you modified something and you again checked in. Okay. Now after you checked in, some people may come to you and say that I'm facing some problems. The automation code is not working properly after your check-in. Okay. At some point of time, some people may point out to you saying that after your check-in, some automation code is not working. They may say you, okay, because of your check-in, the automation code that you have checked in is not working. The complete automation code got disturbed. But you have not done any mistake, guys. What are the mistakes that has been done by Mr. A? How to overcome this problem? You got my point, guys? Everyone is continuously working, guys. Mr. A, Mr. B, Mr. C, Mr. D are continuously working on updating this code. But after 3 or 4 days, what happened is when someone tried to run this automation code in their machine, so they are getting errors. Whom should be blamed? Do I have to blame Mr. A, Mr. B, Mr. C, Mr. D? How to find the culprit, or how to find someone who has wrongly committed the code, wrongly updated the code, pushed the code? How to do that, guys? What is the solution?
Logs.
Logs, no. And any other? Answer. I want the direct answer. Don't dig into the details how that will happen, but at a high level, tell me, this many people are working on the automation code, and on fine day, if I come and say that because of you something happened, what will be answer? You are not the culprit, but still I will say that because of you something has happened. What is the solution for this?
We can check the, suppose who registration module is affected, so we will check who is at the recently who updated the registration module.
Okay, that's one solution, but it was very long time that I cannot find out. I cannot trace actually. That's the problem. I cannot trace because it's like after a week I cannot say, because many people has worked on the registration. Even you has worked on the registration. Let's say that everyone has worked on the registration, and only one person has done the mistake. In a week, everyone has done automated the registration functionality. Somehow they modified it. Everyone has put their hands into that registration. Now, how can I figure out the person? It's not about figuring out the person who did the mistake, but there should be some process, right? That process is nothing but, instead of waiting for the complete week, every day, based on your project requirements, some people may want their automation code to be very clean. That means after every check-in, they want the automation scripts to be run automatically. Okay, after every check-in, that may also be there. And some people more want to check their automation code every day. Okay, there is a problem, right? Because you cannot wait for a week and say that you did a problem. Instead, you would have found this problem on the first day itself. What generally we will do is, we will take the help of this Jenkins guys. Okay, Jenkins, what it will do is, based on the timer set or whatever that is, it will automatically pull this code from the latest centralized repository code, and it will try to run at a particular point of time. Today at 12, midnight 12, it has run the automation code of this particular thing. Tomorrow morning, if you go to work, right, you will see all the results. Okay, and based on the results, you can identify who has worked on the particular day on the particular functionality and figure out. But in a week, can you find out? In a week, is a good thing to find out after a week or in a day? Tell me, guys.
In a day.
In a day is a better one, because you can easily find out, right? One day you can easily find out what happened and what went wrong, what didn't went wrong. Okay. So every day you need to run at least. This is at least. Sometimes if the automation code is very less, it can be run multiple times. Frequently throughout the day, it can be run. Okay. Jenkins jobs will be running throughout the day. Thing is that if you plan this set up Jenkins in such a way that every 12 hours, if the automation code that has been written so far is run, if you find any problems, what will happen? We have to revert the code on a single day, and then we can again modify the code in the proper way and then continue the work, rather than waiting for the complete week and trying to figure out who did the problem. Okay, that's not the solution. Rather, we have to continuously run the automation code. Okay, continuously. How frequently you run the automation code, that much solution will get. Okay, the number of times you run the automation code, that many times, that much benefit you will get. That's what is the solution. At least you need to run your automation code on a updated automation code of centralized repository, and at least on a daily basis. If today you find some problem, what you will do, you'll revert to the latest yesterday's code and try to push the code again. Okay, you'll go back, you step back and then come forward, something like that. It's better that our automation code gets executed frequently instead of waiting for the complete 1 week and then running this code. Okay, instead of running the code after 1 week, you have to run on a daily basis to see things going smoother. The issues should be resolved as soon as possible. Okay, to make this possible, we have to go with some concept known as continuous. What is that, guys? Continuous
Integration.
Yes, integration. This concept is known as integration, continuous integration. In continuous integration, we'll use the tools like Jenkins. Using which the code will be automatically. You don't have to manually run the code, guys. Okay, Jenkins at particular time at midnight 12 it will get activated, and then it will come to the code, and whatever the code that is there, it will take the code and run it. Okay, you don't have to be there before the machines. Jenkins will do that task for you. Okay, automatically. At that particular point of time, it will come and collect the code and run it. Okay, why it has to frequently come? In case if you forget to run the code also, no problem. Jenkins is automatically set in such a way that at midnight 12 it may come and then run. It doesn't mean every day midnight 12. It can be any time, guys. I just took an example for midnight 12. Okay. So it can be anything. It can be anything. Whatever the time you mentioned Jenkins, right? At that particular time, Jenkins will come and collect the code and run the code. Okay. How frequently you want to run? You have to specify in the Jenkins based on your project requirements. You have to specify the frequency in which this automation code need to be executed that many number of times. So that process is known as continuous integration. You should not be waiting for the complete code to be automated. Rather, you have to execute the code. Whatever the so far code created, you have to execute that on a daily basis at least. In this way, the problems will be resolved. At the same time, version controlling and collaboration should also be possible. That will be possible with the help of Git and GitHub, whereas continuous integration, continuous automation execution of the code will be done by Jenkins, whereas Git and GitHub will take care of the version controlling and collaboration part. Okay, how can the Jenkins where can the Jenkins take the code from, guys? Tell me. Jenkins will take the code from where? Automatically it has to run the automation scripts. From where it will collect the code?
GitHub.
GitHub is nothing but the centralized repository. This part is nothing but GitHub. Okay. This is a GitHub, guys. Whatever you are seeing the circular diagram, right? This is a GitHub, centralized repository. For centralized repository, a cloud kind of thing where you will host all your code. Okay. Everyone. These are the local machines. This is the GitHub. And here check-in, checkout, update are there. What are these things? How can this be possible? Check-in, checkout, update. How can this be possible? Using which tool?
Jenkins.
This is GitHub. How this check-in, update, and checkout is possible? Using which tool?
GitHub.
GitHub is a centralized repository, not for check-in, checkout, update. Git commands will be there, guys. I will explain what is Git. You will understand. Okay, GitHub is centralized repository, and to retrieve the code from the GitHub and copy into this local machine, or to update the code into your local machine from the centralized repository, or to update the centralized repository with this replace the centralized repository with this code in your local machine. Okay, for that you need something known as Git commands. Git commands will be there, guys. Okay, Git commands will be there. Okay, here you can understand properly, I guess. So this check-in, check-out, all those things update are done by Git. Okay, Git commands. CR, centralized repository, is nothing but GitHub. Centralized repository is nothing but GitHub. How to continuously here Jenkins will come into place. Here somewhere Jenkins will be there. Okay, whatever the time you specified, it will come to your centralized repository, collect the code, and automatically execute the code. okay, on a daily basis or whatever that is. Got some clarity, guys? Got some clarity? Any questions, any doubts, any confusions? Clear it out, guys. Okay. Guys,
No question.
okay, fine. So for centralized repository, we'll be using GitHub for all these commands for checking out, checking in, updating. This particular task will be done by Git commands. With the help of Git commands, we'll interact with the GitHub with the help of these Git commands and retrieve the code or update the code or whatever that is into central repository. And whatever this environment is there, okay, this centralized repository will have the latest code. No matter at what time of the what you are doing, with blindly Jenkins will come to this particular centralized repository at particular point of time, and whatever the latest code is there, right, it will execute that. Okay, this Jenkins will automatically execute this code instead of we taking we doing this. Okay, instead of we doing continuously, Jenkins will automatically do. It will not forget. We may, as a human beings, we can forget, but Jenkins will not forget. It will automatically come here and run it. Okay, fine. So this is the concepts, guys. These are the concepts. So hope these concepts are clear. Jenkins, Git and GitHub concepts are clear. Theoretical. These are the theoretical concepts. Real-time theoretical concepts.
Yes.
Okay, fine. So shall we take this today or tomorrow? It's up to you. If you want me to take it today, I will take it today. Otherwise, I will take it tomorrow. Up to you guys. Shall I take it? Guys, anyone respond? If you are fine, I will take it today.
You can take it, but ask others.
Okay, fine. What about others, guys? Sudeshna?
Better it will be, you will take it tomorrow.
Okay, fine. But so far concepts are good or not? Like understood or not? Today's concepts.
Yes, yes, yes.
Clear, right? But go through the recording once again if you feel. Okay. Just practice. I understand that it's kind of too much theoretical, but there is no other way. Okay. And if you understand, I will take it tomorrow. No issues. I'll take it tomorrow, guys.
Okay.
Tomorrow it will be completely practical. Okay. I'll be configuring GitHub, Git, Jenkins. Okay. Practical. I'll be configuring all this stuff. Okay. So this part, get ready, guys. Just understand this section. Theoretically understand this section, and if you have any doubts, you can ask me tomorrow. Okay. In tomorrow's session, you can ask me. And guys, see you tomorrow at same time. We'll explain the practical things tomorrow from tomorrow. Okay. Bye, guys. Thank you.
Thank you.